I'm Anil Kumar, sharing with you some questions from the previous test papers. The question here is based on principle of inclusion and exclusion. There are two questions on this page. The first one is, there are 9 actors in the play Macbeth and 14 actors in the play A Twelfth Night. If there are 5 in both, how many actors are there in all? So we can actually draw a Venn diagram and solve this question. Very similar to this is the next question, which is there are 18 players on the hockey team and 24 players are on the basketball team. If 32-seat bus is ordered, how many are in both the teams? You can pause, answer the question, and then look into my suggestions. Now, one way to solve them is to draw the Venn diagrams and get the answer. The other one is we could straight away apply the principle of inclusion and exclusion. Let's begin by sketching the Venn diagram actually. So two items, so we have 2 circles. And let us say that, so we have 9 actors in the play Macbeth. So let's say this is for Macbeth, and there are 14 in the play A Twelfth Night. So this is T, the 12th night, and there are 5 in both. That means 5 is common here. Now, in Macbeth there are 14. Therefore, in this portion, how many should be there? 5 is to be taken out from 9. There are 9 players in Macbeth. So 9 minus 5 gives us 4. So we have 4 here. And 14 in A Twelfth Night. So the number here should be 14 minus 5, and that is 9. So that gives us 9. How many actors are there in all? We can add them all. So the answer is total number of actors should be equal to 4 plus 5 plus 9, and that is 18. So that is how we get the answer 18. So this is how we can do using the Venn diagram. The other way to solve such questions is to use the principle of inclusion and exclusion. As you can see here, the players which are common to both, the actors which are common to both, if you add them up, 9 and 14, they are counted twice, right? So we have to exclude them. So the other way is you can add 9 and 14, right? So number of players in Macbeth plus number of players in the 12th night, okay, minus the number of players which are common to both, right? So intersection of Macbeth and time. So that is how you can also get the total number of players, I should say NM union N in T, right? So that is how you could get total number of players. Now in our question, we are given these numbers. These are 9 plus 14, take away 5, correct? So when you do that, you again get 18. So this is another way of doing, and we call this principle of inclusion and exclusion. Remember, we cannot do simple addition since the numbers which are common in both get added twice, so they should be excluded, and that is what the principle of inclusion and exclusion is. The second question here is, there are 18 players on the hockey team, 24 players on the basketball team. If 32-seat bus is ordered, how many are in both, right? So we can now directly use this equation, how many are in both, right? So we could write equation 32 is the total number of players. Players in one team are 18, in the other team are 24, and we need to exclude number of players in both, right? So let that be X. So we could simply find this now. So we have X as equals to 18 plus 24 minus 32, right? So that gives us the answer 18 plus 24, 8 plus 4 is 12, 1, 42, take away 32, and that gives you 10. And therefore the answer is 10. So we have used the principle of inclusion and exclusion. So basic formula here is that the total players, right? So total is equals to number of players who play hockey plus number of players who are playing basketball, take away the players which are in both the teams, that is hockey intersection basketball, right? We are given total, which is 32, correct? Numbers in hockey is 18 plus 24, and this is what we need to find. And that is how you do it. I hope with these examples, the concept of inclusion and exclusion is absolutely clear. I'm Anil Kumar. You can subscribe and share my videos with your friends. Thank you and all the best.